4-4 is where we're at today, and yes, we are skipping 4-3. 4-3 had a lot of graphing, pretty in-depth graphing calculator work, so we're going to skip that. We're not testing you on it. We're going on to 4-4, and this is going to be a section that lots of you like because you came out of exponential algebra really, really good at factoring. And that's what we're going to do for the next 3 days that we're together. So that'll be today, Monday, and Tuesday that we'll be talking about all the different kinds of factoring. So we're factoring quadratic expressions, which are parabolas when we graph them. And what we're trying to do is break them down into parts. Now, most people would look at this and say, well, how does that fit in with what we were doing the last 4 days, which is all this graphing stuff with vertex form and standard form, and why do we do this now? Because this is going to give us even more information about our graphs. And so what we want to do is have all of this available to us so that we could basically make a graph of a parabola without ever having to grab a graphing calculator. So we're going to find common and binomial factors of quadratic expressions and factor special quadratic expressions as our objective. And like I said, there are lots of different things that we need to see. We've got 3 days packed with all of this good factoring to do it. So to start with, we want to understand that to get to our objective of factoring quadratic expressions, we first have to understand how FOIL works. So when you do FOIL, it's a mnemonic device, which means basically it's just something to help you remember how to make sure that you get all the steps done when you're multiplying two binomials together. So what we do is FOIL by taking first times first. So in this one, we would take 2x times x because those are the first terms in each of those sets of parentheses, and that would give us 2x squared. And then we need to take outside times outside, and that would be 2x times -5, which is -10x. Then we take inside times inside. 3 times x is going to be 3x. And then we take last times last. 3 times -5, which is -15. Now, if you're using this method, you're going to know that you're done when you can see a little FOIL guy. So there's a little FOIL guy right there. And we're not done with the problem, but at least that lets us know we have done FOIL. FOIL, just like I said, is a mnemonic that helps you get every term in the first parentheses multiplied by every term in the second parentheses. That's all it does. But when you learn FOIL early on, it really helps you to see how all of that comes together. So now, I know that 2x squared is there on its own, but I do have 2 x's that I can put together, so these are like terms. -10x plus 3x will be -7x minus 15. And now, I don't have any more like terms. One is an x squared, the other one is an x to the first power, and the other is a constant. So when we're factoring, what we're doing is taking what I have in the red here, and we're working backwards to find those two factors, those 2 sets of parentheses that we could break this into. And math is all about being able to do things forwards and backwards, show how something works, and then be able to undo it. Now in the next one, we see a special pattern. And this special pattern is called the sum and difference pattern because sum means adding them together and minus means difference, it's subtracting. So first times first will give us x squared. Outside times outside will give us -9x. Inside times inside is plus 9x. And last times last is -81. And here's the really cool thing that happens when you're using the sum and difference pattern, and that is the two middle terms cancel each other out. So I have my x squared in the front, and then I have -9x plus 9x, and that cancels out, which gets me thinking, well, in the future then, if I see that pattern, first and second terms are exactly the same in the parentheses, but one has a plus in between and the other one has a minus, I'm not going to even bother doing outside times outside plus inside times inside. I'm going to skip that part because I know that those two will cancel each other out. Now the next one also provides a special pattern. This is called a binomial, meaning it has two terms, a binomial squared. So this is the quantity x plus 5 times the quantity x plus 5. How do I know that? Well, here's my power. And remember, powers work for the thing that's closest to them on the left. And the closest thing to this power right now is parentheses. So that's telling me I have to put the whole parentheses down twice. And then I can go ahead and do FOIL. First times first, x squared. Outside times outside, plus 5x. Inside times inside, plus 5x. Last times last, plus 25. Now notice the second and third terms are exactly the same. So what really happens is we get two of those. That term is always doubled. So x squared plus 10x plus 25. Keeping in mind, we are going to have to be able to take this and put it back in the form the quantity x plus 5 squared. But understanding it forward helps us understand it backwards. Then I get to the quantity 3x times the quantity 5x plus 2. And I realize, well, that's not FOIL. This one is just distributing. I need to multiply 3x times everything in the parentheses. That's exactly what we do. 3x times 5x is 15x squared, because x times x gives you that x squared. And 3x times a positive 2 gives you plus 6x. Again, thinking in advance, I'm going to have to take this, and I'm going to have to make it look like that in today's lesson. So, understanding the things forward that we do to multiply binomials, or in this case a monomial, one term times a binomial, can help us figure out how we can work backwards in this process. So, we have a lot of vocabulary, as I'm sure you've already noticed, for this. One of the big ones is going to be a binomial, and we have to know that a binomial means it has two terms. Now technically, when we talk about terms, terms have to be separated by addition, but we're just going to think about the fact that if we have parentheses and we have a plus or a minus in between two terms, then that's a binomial. And then number 2 says greatest common factor. Now that's going to be the first thing we look for whenever we are going to be factoring. Is there something we could take out of all of the terms that we see that would make this easier to do? So a greatest common factor is the largest number and or variable that divides evenly. Out of every term. So let me read that off again so you can get that down in your notes. The largest number and or variable that divides evenly out of every term. That's the greatest common factor. So thinking about that, we see number 3 looks pretty involved. And as I said, the first thing we do whenever we're factoring is we try to take out a greatest common factor. So I'm looking at this and thinking, well, maybe I can take an A. This has an A. In fact, it has 2 of them. This has an A. Oh, I can't take an A out of that one. There's no A. Maybe I can take an X. This one has 2 X's. This one has 1 X. Rats. That one doesn't have any at all. But this is actually a great factoring pattern that we're going to spend quite a bit of time on Monday. And this happens to be what's called a perfect square trinomial. So the question that you should be asking is, well, how am I supposed to know that? You know, when I look at this thing, how am I going to know this is a perfect square trinomial? Because this is a and x both squared. And the last term back here is c squared. Now, when we multiplied this out, knowing the forward piece here, we saw that when we had two of them that were exactly the same, we got a perfect square for the front, a perfect square for the back, and the two middle terms were exactly the same. And that's the reason we could write it as a binomial squared. So what I have to check for is, if I multiply these together and take it times 2, do I get that middle term? Well, ax times c is axc times 2 gives me 2acx. Now, I'm not going to worry about the negative at this point. I'm going to show you how to take care of that. So what we had to square was a and x, and then we had to square c back here. Now, to make sure that we get subtraction in the middle of this, we're going to need subtraction in between the two. And then we need that little squared piece. Now let me go back up to 3. Because again, what I'm looking at is, hey, this looks like a and x squared. This looks like c squared. I wonder if this isn't one of those perfect square trinomial thingies. Well, let's see. If I take ax times c and then multiply it by 2, do I get 2acx? And I do. So that one is also a perfect square trinomial. We're going to have that ax in the front and that c in the back, but this time the middle term is positive. So I'm going to put a plus in there. And like I said, that's a pattern we're going to spend a lot of time on Monday, since you guys are not here tomorrow for school. We have staff development and workshop for teachers tomorrow. We'll be here working on all this good online stuff for you. Alrighty, well that one looks kind of special too. So I take a peek at it and I notice, you know what, this is a perfect square again, and this is a perfect square. Because if I take a and I square it, I get a squared. And if I take b and I square it, I get b squared. But wait a minute, there's no middle term. Oh, that happened earlier today when we were multiplying these out. That happened right here, where we had that sum and difference pattern. One gets the plus, one gets the minus, and no middle term. So if I have this, I have to go back and write that sum and difference pattern as two binomials. So that means I'm going to have a plus b and a minus b. And all of these patterns from the last 3 here, we could check by just doing FOIL and making sure that we get back to, in this case, a squared minus b squared. Now, we are going to call this one, as factoring problem, the difference of two squares. In fact, that's when we're going to see so much. We're just going to be automatic with it. Oh, it's two perfect squares with a minus in between. That's a difference of two squares problem. So it's factored to look like the sum and difference pattern. That's another one. These bottom 3 here, lots of time on Monday for those. Today what we want to do is just get your head wrapped around back into that whole how do you factor thing. You know, just general factoring. But every day when we talk about this, I'm going to run through the steps that you should do whenever you want to factor. The first step, whenever we are told factor something, is to try to find a greatest common, it's called a monomial factor. That means one term that you could pull out. So I'm taking a look at x squared, 9x, and 20, and I'm trying to figure out, is there something I could take out of all 3 of those? Well, I can't take an x out of all 3 because the 20 doesn't have one. And I can't take 9 or anything that goes into 9 because it's not going to divide evenly into 20. So I realize, hey, that step's done. You know, I can't. There's nothing in this one that I could do to take out a greatest common monomial factor. Then I'd look for special patterns, and I notice, hey, x squared, that's a perfect square. And then those other perfect square patterns that we just looked at always had the last one as a perfect square. Wait a second, 20 is not a perfect square. Okay, so there's nothing fancy about this one. It's not any special pattern. And then we go to good old-fashioned factoring. And we ask ourselves, what are the numbers that multiply to give me 20, the last term, and add to give me 9? Now I'm going to do this nice and slow with the first couple of these. And so if they didn't pop into your head right away, you'd say, all right, 20, let's see. Nice integer factors. And the integers are the numbers -3, -2, -1, 0, 1, 2, 3, going in both directions forever. So ... We don't want to worry about factoring with fractions. We're not going to do that now. All right, so let's see. 1 and 20. That doesn't add to 9. 2 and 10. That doesn't add to 9. 3 doesn't go into 20. 4 goes into 20. 4 and 5. The 6, 7, 8, 9. Oh, 10's the next one, and I already have that one up here with 2 and 10. So you look at your list and you realize, oh, it's the bottom one. It's the 4 and the 5. Those two will add to 9 right there. That's the one I want. So then we think backwards. How did they get x squared? It had to be x and x, because x times x would give me x squared. And then we just found the two numbers that multiply to 20 and add to 9. It's 4 and 5. And since all of these have pluses, it will be +4 and +5. And if we wanted to check that, we could just do FOIL on it real quick and make sure it works. X squared plus 5x plus 4x, those two add to 9x. Last times last plus 20. And we have it. So sometimes if the numbers aren't coming to you right away, this is a really good method to kind of slow your brain down a little bit, and you might have to grab a calculator and see, okay, what numbers perfectly divide into whatever this is, and go from there. Like it says, step 2 is to use those factors to write that final answer once you've found the two numbers that multiply to 20 and add to 9. All right, in the next one, what is each expression in factored form? And I'm looking for the greatest common monomial factor. I can't take an x out. I can't take a number out because this is a little 1 in front here, so there's nothing I can do to make that smaller. We always want smaller first. Let's see. Well, I guess I need to figure out all the numbers, the list of numbers that would multiply to -72. Whew! There's a lot of them. So you'd grab a calculator, and first, hopefully, you'd say, I don't need a calculator for -1 and 72. You know, that I know. Or +1 and -72. That one's good, too. -2 and +36, you probably don't need a calculator for that one. But then you get to things like 3, and you're like, well, wait a second. 72 divided by 3. Yeah, that's 3 and 24. So it could be -3 and +24. Could also be +3 and -24. How about 4? Does that go into 72 nicely? Hey, it does, 18 times. So -4 and +18, +4 and -18. And then I think, okay, well, 5's definitely not going to go in. We know that already. How about a 6? Oh, 6 and 12. That works. And because we have a -72, we have to do that with the positives and the negatives. All right, well, we know 8 and 9 work. In fact, that was probably the thing that popped into your head when I said we needed 72 was 8 and 9. 10 isn't going to work, 11 isn't going to work. If we divide it by 12, we're back at our 6's right here. So we have all the factors. There they are. And what we have to do is locate the two factors that when we add them together, get us that middle term, which is positive 14. So we're looking around this list and thinking, no, these are too far apart. No, that'd be 34 and negative 34, 21 and negative 21. Ooh, here we go. Negative 4 plus 18. That adds to 14. Now, that would not have been most people's first choice. You know, we don't think of 72 as being 4 and 18. So sometimes it takes some looking. And then we realized we were finding the factors of negative 72 with a sum of 14. And like it says, step 2 is, okay, now use that. You know, think about what's going on here. How did that work? Well, it was because x times x will give us x squared. That's not a mystery. And then in the back, we would need a negative 4 and a positive 18. So that if we did FOIL on this, we would get back to x squared plus 14x minus 72. 72 is a number with a lot of factors. We'll have a lot of them today where you'll like, I know that one, I've got it right away. But we'll also have a few where maybe you have to write them down so that you can remember all the factors that you need to check to see if you can get those terms to match up. All right. So now, this one says, what is each expression in factored form? And I notice something's different about this one than all the other ones. Oh, there's a negative in front. I can't leave that there. So what I have to do first is I have to factor out a negative 1. And all that does is make us have opposite signs for everything else that's up here. So now it'll be x squared minus 13x plus 12. And that has to be our first step. We never leave a negative in front of our expression, our quadratic expression. So we factored out the negative. And now we start thinking, probably I'm not done. Probably I can find two factors of 12 with the sum of negative 13. And the first thing that goes through my mind is, oh, they have to add to a negative, huh? So they have to multiply to something positive, but they have to add to a negative. Oh, that means they're both negative. That's the only way that's going to work. So if it doesn't come to you right away, you start writing them down. Let's see, negative 1 and negative 12. Oh, there it is, right there. That adds to negative 13. I don't need to write down anymore. So now, we can't forget our little negative. I'll leave enough of this that you can see all those pieces. But we've broken down our trinomial into two binomials by finding the factors of negative 1 and negative 12. And we write it out. And again, you could check this. You'd do FOIL on your two sets of parentheses because the order of operations says you have to do parentheses first. Then you'd multiply everything by negative 1, and you better get back to the original that we had up there in black or you did something wrong. So those negatives have to come out. You cannot leave those negatives in the front of your squared term. Alrighty. So now we're going to come to the time where I'm going to ask you questions and get you to help me out here. So x squared plus 14x plus 40. I'm looking for a greatest common monomial factor, and I don't see any. And this is a perfect square, but that's not. So I know that I'm just going to good old-fashioned factoring. And now some of them we're not going to have to make a list for because we're going to be able to find them. So now I know x times x gives me x squared. But I need two numbers that multiply to 40 and add to 14. Unmute and tell me those numbers if you know them. 4 and 10 it is. I don't know if that was the first one that popped into your mind. A lot of people would probably go with 5 and 8, but you'd realize right away, oh no, those add to 13. That's not right. And so you'd keep looking. And yes, if you need to make the list, you keep making the list. I don't care on the test if I see lists all over the place. That's fantastic. That lets me know you know what's going on with these. Alrighty, I look at B. And I realize there's nothing I can take out of all of those. It's not a perfect square trinomial because 30 is not a perfect square. I need two numbers that multiply to positive 30. Oh, but they have to add to negative 11. Multiply to positive 30 and add to negative 11. Unmute and give me those numbers.
6 and 5.
-5, -6, -6, -5. There they are, because we have to add to a negative. Alrighty, take a look at C. I think we have some work to do before we can get to that factoring piece we were just doing in B. What do we have to do first?
Pull the negative out.
Good, 2 people told me. Fabulous. So we will have x squared minus 14x minus 32. Now we might not be done. I mean, it still has a squared in it, so maybe, just maybe, this one we can keep going on. So now we would need two numbers that multiply to give us negative 32 and add to negative 14. Think about that one for a couple of seconds. Multiply to negative 32 and add to negative 14. Then unmute and tell me what they are if you know them.
16 and negative 2.
Careful.
Negative 16 and 2.
Mm-hmm. There it is, because negative 16 plus 2 would give us the negative 14. So that sign is going to be very important. Again, if you looked at 32 and you said, wow, okay, 4 and 8, that came to me right away. Oh, that's not going to give me 14 in the middle. Well, sometimes you make the list. You know, you start going through 1 and 32, 2 and 16. Oh, look at that, it's 2 and 16, but one of them needs the negative. So whether or not you make the list or not is up to you, and whether or not you feel you need that list. And sometimes you're going to get a number that has a ton of factors. Let me give you, for instance, 108. I mean, it's not something that showed up on your multiplication tables when you were in elementary school. So sometimes people have to write those down. You know, they have to sit there and think, okay, 108, 2 and 54, you know, and then just keep going through them. And that's perfectly fine. If you find it, that's all that matters. Now, this one says, let's start looking at that first step that I mentioned. Our first step will always be, if we have a greatest common monomial factor, we need to take that out first. Our job is to factor this the best way possible. And factoring with smaller numbers is always the way to go. So, what is the expression in factored form? And the first thing I noticed about A that's different is it only has 2 terms. And then the second thing I notice is, hey, there's a number in front of that n squared. I don't like that there. So I start thinking, is there something that would divide evenly into both 6 and 9 and n squared and n that I could take out of this before I tried to do any more factoring? Find something that'll come out and unmute and tell me what it is.
3n.
Yeah, not only can we take a 3, we can take an n. Yeah, because 3 divides into both of those numbers nicely. And so does n. So now we're going to work backwards, because usually it's easier for people to think multiplication versus division. 3n times something has to give me 6n squared. Well, that's 2n. 3n times something has to give me 9n. Well, that's 3. And now notice inside the parentheses, we no longer have anything squared. That means we are definitely done factoring, because we can only continue factoring if we still have some variables that are at least to the second power and beyond. So that one's done. I know you look at that and you say, well, that's not factoring like I think of factoring, but we did factor. We factored 3n out of it. We took a common monomial factor. That's, let me write down that name so you'll remember that in the future. Common monomial factor. Now, mono just means one. So we took one term out of the whole thing. 3 and n connected together are called a term. All right, now I go down to the next one. And I'm looking at it, and I'm thinking to myself, okay, we got a number in front of the x squared again. I wonder, can we take a 4 out of all of these? So we'll give it a try. Again, you can think forwards with multiplication or backwards. So 4x squared divided by 4 would be x squared. 20 divided by 4 is 5. And then, yeah, you'll probably have to think about it for a second. Let me write it down so everybody can see. 4 goes into 5 once. You do your subtraction and you get 16. So 4 and 14. And it looks like so. Now we have technically factored. It's just that we might not be done yet. We have to factor these completely. So we want to try. We know that x times x gives us x squared. And we're hoping that we can find two numbers that multiply to negative 14 and add to 5. If you find them, unmute and let us know what they are.
7 and negative 2.
7 and negative 2 multiplies to negative 14 and adds to 5. Now we have factored completely. So we factored out a common monomial factor, and then we did some good old-fashioned factoring, and we have it factored completely. So like I said, what we want to do is factor either until there's no squareds or higher powers left, or get to a point where we're like, uh-oh, that's not factorable. Then we're done. Alrighty, what is the expression in factored form? I want more help this time. Unmute and tell me a thought about A, 7n squared minus 21.
Pull out 7, Travis.
Just a 7 this time, everybody? Okay, 7 comes out. Oh, gosh, I wonder if that's factorable. N squared minus 3. Well, earlier on we said if this is something squared and this is something squared and they have a minus in between, that's a sum and difference pattern. Is 3 a perfect square?
No.
No. 1 squared is 1, 2 squared is 4. We're already past 3. So that one's done. We did the factoring that we could do. There's just nothing else that we can do without starting to talk about square roots and all this other stuff. And that's not what this is about. This is about breaking it into nice integers. B, 9x squared plus 9x minus 18 equals. Oh, is there a common monomial factor here? Is there something we can take out? What is it?
9.
Take the 9. So again, you can work forwards and say 9 times something has to give me 9x squared. That's x squared. 9 times something has to give me 9x. That would be an x. 9 times something has to give me negative 18. That would be negative 2. Or you can divide everything by 9. But this 9 does not disappear. It has to come along for the ride, because remember, this has to work forwards and backwards. So when we're done, if we multiply our answer, we have to get back to this original right here. Alrighty, let's see. Maybe we can keep going. Well, we already said this isn't a special pattern. A negative 2 in the back is not a perfect square. So we need two numbers that multiply to -2 and add to 1. If you can think of those two numbers, unmute, tell me what they are.
2 and -1.
Yes. Now we're done. No more squares. It's looking good. All right, if you haven't already, take a look at C, because I'm guessing you're a little ahead of me at this point. I need a greatest common monomial factor if you see one.
4.
Yeah. Again, either divide by 4 or think backwards with multiplication. So this would be x squared because 4 times x squared is 4x squared. And then we'd need a 2x in the middle in order to get our 8x. And then we need to multiply by 3 in the back to make that work. Now, it still has a squared. Maybe, just maybe, we can find two numbers that multiply to 3 and add the 2. Thoughts on that one?
3 and -1.
But then it won't multiply to +3. It'll multiply to -3.
So we're done.
Are we done? I'm hearing from the same two people. I want to hear from some other folks. Is this done? If it is, unmute and say, it's done.
It's done.
Give me one more, it's done, somebody.
It's done.
All right, it's done. So with this one, we feel, I don't know, I guess a little kind of disappointed because it's like, really, all we can do is take the 4 out of there. We can't go any further than that. But we did our job. We factored it. We factored out a 4. We did what we needed to do. And this one is called an irreducible quadratic. And that's something you talk a lot more about in pre-calculus and college algebra than we do at this level. What we need to know at this level is there are not two numbers that multiply to 3 and add to -2, at least not two integers. You know, there might be some nasty stuff out there, decimals or square roots or something, but not two nice integers that are going to do that. So now, one more step up for today. And this is factoring ax squared plus bx plus c when this number in front is not just a 1 or a -1. And you could argue, well, we just did some of those Cedar home, because we did. We pulled out a common monomial factor and then we could keep going. But what if you can't divide out a common monomial factor? Well, then things get interesting. So, what is the expression in factored form? 2x squared plus 11x plus 12. The first thing I would try is getting rid of that 2. I'd say, you know what, if I can divide this by 2, I'm going to do that. This would give me x squared. Uh-oh, 11 divided by 2, that gives me a fraction. Rats. Can't do that. So this comes back to what I started talking to you about today, which is we have to remember how it worked forwards in order for us to work it backwards. Here's what I know. First times first has to give me 2. So I'm going to write down the numbers that multiply, the nice integers that multiply to 2. 1 and 2, 2 and 1. Has to be. There are no other choices. Then I go to the back and I look at C. And I say to myself, self, it's got to multiply to +12 and somehow add to +11. They must both be positive, and they have to be numbers that divide nicely into 12. So it could be 1 and 12, 2 and 6, 3 and 4. Now notice I wrote my A's forwards and backwards, 1 and 2, 2 and 1. Now what that does is it makes sure we get every combination of numbers out here that will work. And now here's the really important part, because it's been a while since you factored. What we have to do is retrain our brain to do outside times outside plus inside times inside. See my hands? That's hard for your brain to do. You look at the outside numbers first and multiply them. Then you multiply the inside numbers, and then you have to add those together. Outside times outside plus inside times inside. So here's what I do. I realize these are going to be my outside numbers, and these two will be my insides. And again, these will be my outsides. And what I have to do is check them until I find the combination that somehow adds to 11. So up here, I would have 1 times 12 is 12. 2 times 1 is 2. 12 plus 2 is 14. That's not right. So let me try 1 and 2 and 2 and 6. 1 times 6 is 6. 2 times 2 is 4. 6 plus 4 is 10. Oh, closer, but not quite 11. All right, let's try this one. 1 and 4 is 4. 3 and 2 is 6. Well, now we've got 10 again. So this one doesn't work. Let's scratch that one off. Didn't give me what I wanted. So now I'll go back at it again with 2 and 1. So this time outside times outside is 24. Inside times inside is 1. 24 plus 1 is 25. That's not it. Outside times outside is 12. Inside times inside is 2. 12 plus 2, 14. That's not it. 2 times 4 is 8. 1 times 3 is 11. 8 plus 3 is, and I said it backwards because I gave you the number first. I hate it when I do that. 2 times 4 is 8. 1 times 3 is 3. And 8 plus 3 is 11. Now, pretty obviously, order is important. I had a lot of these that didn't work before I came to that outside times outside plus inside times inside piece. So what I have to do is make sure that I put them in the exact same order that I see them up here, because this was first, 2x, times first, 1x, and this was last times last, plus 3 and plus 4. And again, if we do FOIL on this, we better get back to 2x squared plus 11x plus 12. So we start by saying to ourselves, how are we going to get first times first to give me 2? How am I going to get last times last, multiplying to positive 12 while somehow adding to positive 11? Now, here's another trick. The book writers know that as math students and math teachers, we're generally going to start with the smallest numbers and go down to the biggest numbers as we make this list. So what do the book writers do? They usually make it one of the bottom sets of answers because they know that'll make us check a lot of them before we get to where we are. So one of my tips would be start at the bottom and work your way back up. Usually that'll be a big time saver to do that. But we want to become good at it either way. So however it works for you. Alrighty. This one says, what is the expression in factored form? And I need lots more help on this one. So is there a greatest common monomial factor we can pull out? Unmute yourself and answer me.
No.
Nothing? No, you first think about the 4, but then it's not working, right? Okay, so now I need all the numbers that divide into 4 evenly. 1 and 4? What else?
2,
2 and 2. 1 and 4, 4 and 1, 2 and 2. Now there's no point in writing 2 and 2 the other way because it's still going to be 2 and 2. Okay, well that's good. That's not a long list. Now in the back, they have to multiply to negative 3 and somehow add to a negative. So that tells me one has to be positive and one has to be negative. So give me some nice numbers that will work for negative 3.
Negative 3 and 1.
Anything else we should use?
Negative 1 and 3.
Yeah, because the sign could change. Do we have any other alternatives if we're just looking at integers? That's it for the list, right? Okay. So now we have to do that retraining. Eyes, don't fail me now. Outside times outside plus inside times inside. See if you can find that -4. If you found it, please unmute and let everybody know.
2 and 2 and 1 and -3.
Outside times outside is -6. Inside times inside is +2. -6 plus 2 is -4, which is what we needed in the middle. So now be careful when you're writing your answer. And remember how we got these numbers. This was first times first, so 2x in both of those spots. And this was last times last, and the order matters, so the +1 and the -3. But in this problem, we could write it as 2x minus 3 times the quantity 2x plus 1 in the back. And you can do that with any of these. So it doesn't matter if you put the 2x minus 3 first and then the 2x plus 1. As long as you have the right factors, you're going to be good. All right, I need more help. Got it. A is 4x squared plus 7x plus 3. Can we take that 4 out?
No.
How about a 2? 2 goes into 4.
No.
Rats. All right, well, that means we have to do, I call this the combo factoring. Because we're really looking at combinations of numbers that'll make this work. So for 4, hey, we just did that one in the last problem. 1 and 4, 4 and 1, 2 and 2, and that 1 looks kind of weird. All right, our numbers in the back have to multiply to +3, and somehow outside times outside plus inside times inside has to give us a +7. So what numbers are we looking at?
Three and 1.
Yeah, that's it. That's it. So do your outside times outside plus inside times inside. See if you can find it, and then unmute and let us know.
4, 1 and 1, 3.
12 plus 1. Uh-oh. That'll give me 13 in the middle.
1 and 4 and 1 and 3.
3 times 1 is 3. 4 times 1 is 4. 3 plus 4 is 7. Looks good. So again, oh, and I'm writing too big. Let me put it down here. Remember, these came from first times first, and this came from last times last. And again, you could check that, totally check that by doing FOIL and making sure you get 4x squared plus 7x plus 3. Alrighty, let's go to B over here. 2x squared minus 7x plus 6. Can we take the 2? Can we pull a 2 out of all of that? Nah. All right. Well, then it's a combo problem. So I've got 1 and 2, 2 and 1, and now the part that takes a little more thinking. I need this to multiply to +6, but it's somehow going to have to add to a -7. So what kind of numbers will multiply to something positive but add to something negative?
Double negative.
Yes. But 6 has a few of those. It could be -1 and -6. Could be -2 and -3. Well, that's not a lot. And then do your outside times outside plus inside times inside. Trying to find that -7 when you add them together. If you found it, please unmute and tell us what it is.
2 and 1, -2 and -3.
-6, and -2. Oh, I got -8.
-3, -2.
Okay, doing that would take these two. So this will be -3 and -4. Yeah. So we flip those first factors. First, last, and last. And again, the order is important. So if we did FOIL on that, we want to make sure we're getting back to 2x squared minus 7x plus 6. All right, now the numbers are going to get bigger. And that's when it usually takes us a little bit longer to find all the factors. So in C, can we take a 10 out, a 2 out, a 5 out? Is there anything we could take out of C?
I have to leave for a test.
Oh, okay. See, Matt, are we almost out of time then?
You know, we're out of time. Like, next class is starting in 30 seconds.
Oh, for goodness sake. Well, then we'll start with these on Monday. Sorry. You'll have to tell your teacher. Cedar Home went long. Yeah, have a good one.